So group 7 summary. So we've got 3 main things that they can talk to you about, generally in a question, that people get confused. They ask you about reactivity, in which case you talk about the displacement reactions. They talk about testing for halide ions, which is silver nitrate, and they ask you about melting and boiling points, which are van der Waals forces. So, to make sure that we're happy, so first of all, group 7. They are obviously, the halogens are group 7 in the periodic table. Now, there are 3 that we study at AS. They are chlorine, bromine, and iodine. And you need to know their colours and their states. So chlorine is a pale green gas. Bromine is an orange liquid. And iodine is a dark grey solid. So you need to know what they are. Now the other thing you have to talk about is why is chlorine a gas, bromine a liquid and iodine a solid? Why do their melting points vary and boiling points vary? And the reason is, so we can say melting points and boiling points increase down the group. Another way of saying that is the volatility decreases. So volatility tells you how easy something boils. So if something's got a very high volatility, it means that it very easily boils. So volatility decreases as we go down the group. And why is that? What is the type of intermolecular force between the molecules? Yep, so we can say that's because our van der Waals forces increase between the molecules. And why do they increase between the molecules? It's because they have more electrons. Remember van der Waals when you're bonding, the number of electrons you've got, the more electrons, the larger the instantaneous dipole, the more of them that you have occurring. So that's the argument for melting and boiling points. The other main one, which we'll do coming off here, is well, let's have a look at reactivity. Reactivity decreases down the group. Why is that? Well, it's because it's harder for the atoms to capture an electron. Carrying on. Why is it harder? Because it is entering a shell further away from the nucleus. So less attractive. Do you remember the experiment that we did because of it? That we did the displacement, and so they will ask you to talk about, you need to know you need to be able to explain displacement reactions. So often they'll say, okay, that's a trend, now explain an experiment that shows that. And do you remember that is, so am I going to go off here? So for that, we can do the Cl2 plus Br minus, Cl2 plus I minus, and Br2 plus I minus experiments. You need to be able to talk about those. Right, what else did we do? So, we also know about testing for the halides. So, tests for halide ions. And remember we used silver nitrate solution and ammonia solution. So you need to be able to talk about the use of silver nitrate solution and ammonia solution in testing for halide ions. And the final one is you need to talk about disproportionation reactions. Reactions. And there were two that you do of Cl2. There's Cl2 plus water and Cl2 plus NaOH. So you need to know those. And these guys are both redox. Those are both redox reactions. So depending on the question, depends on which route you take. If they're asking you about melting and boiling points, you follow this argument. So melting and boiling points, that argument. If they're asking you about reactivity, this is the route you go. If they ask you about silver nitrate, how do you identify different halide ions, this is the route you go. And then disproportionation reactions is that way. So the key thing is to separate these arguments. The common error is they'll ask you about melting and boiling points and people start talking about capturing electrons. Don't go there, keep them separate, different arguments.